I forgot in these examples to talk about the number of turning points. So the number of turning points has to do with when we look at the final graph of something, how many times the graph turns back around on itself, like this. So this would be a turning point here, and this would, and this would, and this would, every time that it sort of changes direction. The number of turning points is always at up to it could be less, but up to 1 minus the degree. So for this example, we have something that's raised to the fourth power. So the number of turning points is going to be, 3 or less. So it's, since the degree is 4, we take 1 away from that. We know that the end behavior of this is going to be going up on both sides because it's x to the fourth power. And so it could be that we have a graph that looks like this. And so we would have a turning point here. That would be 1, that would be 2, and that would be 3. It could be less than that. Looking at example B, we found that the degree here, this the overall degree of this is going to be something to the third power. So we know it's going to look like this on the end behavior. The number of turning points is going to be at most 2. It could be 2 or less. We could have a graph, in the graph that I just drew, there's no turning points. I could have a graph that looks like this and have that same end behavior, and in this case I would have 2 turning points. And then for this third example, this also was, if we were to multiply this whole thing out, we would have something to the third power. We see that it's something to the third power also because we were getting 3 zeros here. So this is going to have at most 2 turning points.